Hi, once again you're welcome to Gamshare's tutorials. Today we'll be looking at elementary set theory under NTH 101. Please, as you are watching, if you're watching me from YouTube, don't forget to subscribe. And if you're watching me from Facebook, don't forget to like and share the video. Now let's quickly dive into this question that we have on the board here. Now look at the set. Let U be English vowels and your set A is equal to A, I, and U, and your phi be the empty set. They say we should find A complement, we should find U complement, and we should find your phi complement. Even though this very phi is put here as an empty set, we know it will be an empty set or a null set, but I would prefer to call it phi. All right, now quickly, let's first of all write our solution. I have my solution. They said U. My U is English vowels. And what are the vowels we have in English? Remember, we have 5 vowels in English alphabet. We have our A, E, E, O, U. Wow, that really looks interesting. So what next? And we have our set A to be just your A, E, and U, which is your A, I, and U. And they said, and phi. They said this very symbol be an empty set. We said this is an empty set. So, what next? We are asked to find a complement. Now, let's look at complement. What is the complement of a set? What is a complement of a set? For we to have a complement of a set, that means we have a universal set. You can see that the set U here is my universal set. The complement of set A simply means all the elements I can see in set U that is not in A is the complement of the set. As easy as that. So that means my A complement will be equal to all the elements I can see in set U that are not in set A is the complement of set A. So what do you see? I can see A in set A, and A is U. So you won't put A there because you have A in the universal set. So you can say I'm having AA is E here. I don't have E here. So what you cannot see in set A, but you can see it in this set, which is said to be the universal set, is said to be your complement. So I have E, I is here, I is here, O, I have O, U is here, U is here. So these two elements are said to be the complement of set A because they are the element I cannot see in A, but I can see them in the universal set. I hope we are following. Now let's quickly look at number 2. Roman numeral 2, they said U complement. Now let's look at what U complement is. Don't forget that U is our universal set. So if you are taking the complement of a universal set, you're going to be having an empty set. Remember, we said the complement of a set simply means that you have a universal set with another set. And those elements you can see in the other set, in the universal set that are not in the other set, gives you the complement of that set. Now look at what we said. Look at the instance we give here. We said the element you can see in universal set, but you cannot see it here. We give you the complement of this set. Now, coming to the universal set also, the element you can see in this set that are not in this set will give you the complement of the universal set. So what element can you see here that is not here is the complement of that universal set, and you can see that we have nothing. It is absolutely what? An empty set. Is an empty set. So what next? We also say we have our S number 3 now. Number 3 now we have our phi complement. Remember that the symbol is an empty set. The symbol is an empty set. So what do you think will be the complement of the set now? You're correct. I believe someone is already guessing it correct. Wow, that is great. So the complement of this set, don't forget, we said for we to get the complement of this set, all the elements you can see here that is not here or that are not here, it is said to be the complement of that set. So what element can you see here that is not here? Is the complement of that set. Now let's check it quickly. And you can see that I don't have any element here. So that means all the element in set U is said to be the complement of the empty set. So I'm going to be having A. Can you see A here? No. E, can you see it here? No. I, can you see it here? No. O, can you see it here? No. And U, can you see U here? No. So these are said to be the complement of the empty set, which means that the complement of an empty set will give you the universal set. Are we together? So let's quickly look at the next question. So let's look at number 2. Number 2 question. Number 2 says what? It says that if you have your A to be equal to X, such that X is a multiple of 3, find A where the universal set is. Now, what are multiples? Or what is multiple? Multiple simply means repeated addition. Let's take, for instance, if you're given a number 2 and you're asked to find the multiple of 2. Don't forget, every multiple of a number begins from the number itself. Every multiple of a number begins from the number itself. So the multiples of 2 are what? We have 2, we have 4, we have 6, we have 8, we have 10, we have 12, we have 14, we have 16, we have 18, we have 20, and it goes on till infinity. Multiple simply means repeated addition. Pick a number, let the multiple begins from the number itself. Keep adding up. Keep adding up. Now look at, if I give you 4 now, and I say, what are the multiples of 4? The multiples of 4 will be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, like that. Let's look at the multiples of 5. We have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And lastly, to make this last example now, the multiples of 10, we're going to be having 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and it goes on like that. So this is what multiple means. So the multiple of a number simply means you picking up the number, keep adding it up. The subsequent numbers are the multiples of that number. So you can see the multiples of 2 are this, the multiple of 4, multiple of 5, the multiples of 10. Multiple simply means repeated addition for a simple understanding. Now, from our, don't forget, this is not our solution. Let's clean it. I'm only making an example here to make us understand what multiples are. All right, now let's solve our question. They said if A is equal to this, is equal to X, or that X is a multiple of 3, find A where the universal set is. Remember, they said that we should find A. That is the only thing we were asked to find here. Only A. And don't forget that A is a universal set, and at the same time, set A are the multiples of 3. Now, don't forget what I told you. I said the multiple of a number begins from the number itself. So that means set A is going to be what? Starting from 3. Because I'm looking for the multiples of 3. So I'm going to be having 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39 is an infinite set. And you can see this is an infinite set. It keeps going till infinity because we were not given a place where we ought to stop. So this is the answer. A is a set of the multiples of 3. So let's go on to the next question. All right, now let's look at question number 3. Question number 3, it said there was a sport competition in Federal University Ukari. The school awarded 60 medals to the winners. 35 medals were awarded in football, 25 medals in 25 medals were awarded in volleyball, and only 10 winners got medals in both sports. They said represent the information in a Venn diagram. Now, please, I would like you to follow me closely. Let's see how we can represent the information we have in this question in a Venn diagram. Now, let's put up our solution very quickly. Please permit me, in this very question, I'll be using some symbols like cardinality. Get back? Cardinality being represented by N. When we say the cardinality of a set, the cardinality of a set simply means the total number of elements that is contained in a certain set. All right, now let's quickly look at it now. Now, they said the school awarded 60 medals. 60 medals is my universal set. That is the total number of the whole medals that were awarded. We have 60 medals. That is my universal set. So, the total number of my universal set, which is going to be what? 60. Do you see that now? 60. That is the total number of awarded medals completed. The universal set contains everything. It contains everything. So 60. So they said 35 medals were awarded in football. The number of medals that were awarded in football, I denoted football as F, were 35 or are 35 medals. So what next? They said 25 medals were awarded in volleyball. So the number of awarded medals in volleyball are 25. And what next? They said that and only 10 winners got medals in both sports. You can see in both. That means 10 winners got both medals in, they got medals in both volleyball and football in set. When you see and, when you hear of and represents an intersection. So that means the total number, let me use what I have here. The total number of students that got both medals, that got medals in both sports, that is football and volleyball. F intersection V are how many? We have them to be 10. So this is the representation. You see that? So they said we should represent this information in a Venn diagram. Please, before I give a proper representation, I'll be giving two representations of a Venn diagram to explain it very more clearly. Now let's look at what we have here now. Let me draw a Venn diagram here very quickly. I have a Venn diagram here. You can see this is a Venn diagram I have, which is my universal set is said to be 60, and I'm having football and I'm having volleyball. So this is my football, which are how many students that got medals, as in 35. We have 35 medals were awarded in football, and 25 medals were awarded in volleyball. Do you see that? Please, let's take note. Let's take note of something. The whole of this cycle, like this, is 35. Do you see that? And the whole of this cycle is 25. So there is an intersection. We have an intersecting set. That's why I intersected them here. What is intersecting them? We have 10. Keep that in mind. However, look at what I want to illustrate very quickly. The intersecting number is 10. 10 winners got medals in both football and volleyball. Are we following? So look at the whole of this. We said the whole of this is actually 35. But you will notice something, that out of this 35, the whole of this cycle is 35. Remember, out of this 35, I'm having a cut out of how many? Of 10. So which means that this is going to be minus 10. There is a reduction now. If I'm cutting out 10 from this place, I will only be having I'll be having something of this nature. I'll be having something of this nature. It's not longer a complete cycle because 10 is cutting it out. But when it was a complete cycle, it is 25. But now that I have a cutout, this is going to be 35 minus what is cutting it out, which is 10. I just hope you understand. So, same thing applicable here. In my volleyball, remember that the whole of this cycle like this, the whole of this is 25. But in 25, there is a cutout of an intersection of what? 10. So, this becomes your 25 minus 10. We see that? 25 minus 10. So this will give me a proper representation now. Now, this is what they want us to give as our final representation of the Venn diagram. We have 60. So I'm going to be drawing this. I have my football. I have my volleyball. Don't forget I have here to be 10. This is F is equal to 35. And this is my volleyball is equal to 25. So look at 35 minus 10. What do I have? 35 minus 10 is going to be 25. And 25 minus 10 will give me 15. So this is the representation, but I'm not yet done. I am not yet done because how do I know that I'm not done? It is expected that whatsoever you are summing or whatsoever you are adding in this Venn diagram is supposed to be equal to 60. Now, if you're going to be giving it a try, if you add 25 plus 10 plus 15 is not yet 60. So that means I still have another element outside. That means I have other people that might probably participate. Maybe they participated in the sport, but they were not awarded medals. Remember that 60 medals were given. So 25 was given to football and 35 was given to, 25 was given to volleyball, 35 was given to football, and 10 was given to both. And we have some that didn't even get the medals completely. Now, you see that 25 plus 10 is 35. And 35 plus 15 is 50, not even 60, is 50. So you have 50, it's not yet complete. So the addition of whatever you're having is supposed to be giving you 60. But the addition of what I have in this cycle, which are those that we are giving medals, is not up to 60. That means I have some that we are not giving medals. Do you see that? And that is where my neither nor comes in. Those that participated, but they were neither given medals in football nor were they given medals in volleyball. So this is a representation. I'm having my N, your F intersection V complement. That means those that were not awarded medals in both football and what? And volleyball. We don't know. It is outside the Venn diagram. So how do we know these ones? It is very easy. The simplest way of calculating this, we do it this way. Actually, if you want to take, if I want to take the union of this, I'm going to be having your N F union V is going to be equal to the sum of what we have. That means I'm going to be having it to be your N F intersection V complement. This one simply means only F and not V. Look at only F and not V. That is, I have only F excluding V plus what? Plus N F complement intersection V, which means only V and not F, which is 15. Then I'm having plus your N F intersection V. That is what is intersecting the whole of them. So if I'm taking the union of this, I'm having my N intersection, my N in bracket of F union V is going to be equal to only F is 25. Look at only F and not V is what we have here, which is 25. So you're having 25 plus only V now and not F, which is what? Which is 15 plus F intersection V. Which do you have here? What do you have here? We have 10, which is 10. So this is going to be equal to what? We have it to be equal to 50. So you can see that my neither nor is outside. That is F intersection V complement is outside the cycle. So how do I look for it? It's very easy. The way to look out for this is to take your universal set. Your universal set, the total number of the universal set is equal to the total number of your F union V plus your N F intersection V complement. That means your universal set is going to be equal to the number of those that were awarded medals plus the number of those that were not awarded medals completely. So you can see that what I have here, what do I have here? My this is 60, right? You can see I'm having 60. So this is 60 is equal to, what do you have? I'm having this to be 50. Remember, we calculated it plus what? What do you have now? And I'm having this to be same thing. That is what I'm looking for. It is an unknown. It is an unknown. So we don't know what it is. I think the place is filled up. Permit me to just clean up. Oh, I should have cleaned there. Anyway, let me just clean up this very space very quickly. Let me clean it up and continue here. So I'm having my 60. Let me rewrite it. My 60 plus, my 60 is equal to your 50 plus NF intersection V complement. Remember, I don't know what this is. So let me quickly look for it. How do I look for it? I'm going to be looking for this by taking this 50 over to the other side. So I'm going to be having my 60 minus 50 is going to be equal to your N F intersection V complement. So 60 minus 50 will give me what? 60 minus 50 is 10, and I'm having N F intersection V complement. So you can see that what I have outside is 10. So that means those that were not awarded medals completely are 10. We have 10 sportsmen or 10 sportswomen or mixed that we are not awarded medal. We have only 10. If you wish, you might also wish to write it this way. Students get confused sometimes. Please, 10 is equal to this is the same thing as you writing conversely your NF intersection V complement to be equal to 10. It is still correct. Whichever way you put it, you will still have it. So now, if you come here now, let's take the addition of what we have in this Venn diagram. If it is equal to 60, now let's take out. You can see that 25 plus 10 plus 15 is 50. Then 50 plus 10 is equal to what? 60. And I have a complete Venn diagram. Now let's quickly look at the next question.